Hi, everybody. Welcome back to Global Satellite Engineering's podcast. As always, today with me here is Jeffrey Palmer, and today we're going to talk to you a bit more about the real estate in space. We spoke a little bit about why we're so good at it, and today we're going to talk about some of the networks that function in space. So we're diving deeper into technology, and we want to talk about comparisons of the different satellite networks, why we work with them, what they do for us, and how they can benefit you as our customers. It's fitting timing as we see lots of these developments and big names like Starlink and Apple, and we see NVIDIA driving AI, and there's so much buzzwords and so much talk around what's happening on all fronts, and things are changing so rapidly. Jeff, tell us, please share some insights. How do we keep up with everything? Where do people start when trying to figure out what network and what technology is right for them? Why have we chosen the ones that we work with to deliver the cutting edge solutions and advancements that we have and that we offer to our customers?
Yeah, great question, Rene. Since there are so many satellite networks in the sky, some of them really pull in a lot of marketing and reach to consumers like Starlink does. And everyone's very familiar with the name. It's like a household name at this point. But we really have to sit down and analyze what they're capable of and what their network is not capable of, and how that applies to a customer's solution. There's many traditional networks or L-band based networks that we provide a lot of connectivity through. Those would be companies like Inmarsat, which Viasat recently acquired, and Iridium, Globalstar, Thuraya. Some more specialized networks like Kinéis from France as well. Some new satellite networks coming like Satellite IoT that are focused on running GSM signaling to space, as well as taking into consideration the orbital patterns of these different networks and how they connect to ground stations. We won't cover all of these individual topics today, but just some of the high levels. Right, there's LEO, MEO, and GEO orbits that dictate where the satellite can see on the ground and whether the satellite is also moving in relation to the user on the ground. And generally that affects things like terminal design. Starlink is quite unique in this category by first having to develop a new terminal that uses a phased array beam that can track a VSAT beam on the ground. And that's really one of the reasons why VSAT traditionally before Starlink was a geo-based network, and Starlink created a terminal that was capable of tracking the high frequency Ka and Ku band connectivity via a flat panel on the ground. And that's what allowed them to launch so many satellites at a low orbit with the orbit pattern changing to the user on the ground. But let's get back into the L-band networks. The frequency is a really important component of this. Starlink uses Ka, Ku band, so does Kuiper when Kuiper is launched, and OneWeb. These frequencies have very high environmental absorption rates in cloudy, rainy environments. And the communication networks that we utilize for telecommunications, for tracking IoT connectivity, they operate in L-band, which is a much lower frequency, centered around the GPS band, right, 1.5, 1.6 gigahertz. And these frequencies don't have the environmental absorption like VSAT does, which means that they can operate the same in pretty much any environmental conditions. It's also why GPS is there. The limitation is that it's a relatively narrow band, and because it's a narrow band, everyone is sort of competing to get a little slice of that same space segment. That then relates to the amount of bandwidth that you have available to the user terminal, because there's a number of networks that are stacked up against each other, and most of them are allocated somewhere 5, 10 megahertz. Where in the VSAT realm, right, when you get into high bandwidth, like internet connected terminals, you have many gigahertz available, like thousands of megahertz available. This is why there's such a differentiation between these small L-band terminals. They operate very well in around the globe, but they also are not high bandwidth terminals, or why airtime is much more expensive on these terminals. You'll find that L-band networks typically have relatively smart terminals that are doing computation at the edge, triggering events and things like that, where VSAT terminals are really just about shoving or pushing data over the air. Let the server or the client figure out what this megabit data stream means, right? Do video and things. Quick note on orbital patterns and connectivity as well, right? So Iridium is a low Earth orbit network. They are a truly global network. They operate from North Pole to South Pole. Their satellites interlink with each other and cross satellites to get to a ground station to downlink the data. Globalstar uses the bent pipe architecture, so there has to be at least one ground station within bent pipe bounce of the satellite to the user terminal on the ground. There are a few ocean regions and north and south regions where there's just not reach of a ground station to a satellite to the user terminal to see. Globalstar has great terrestrial coverage, but there are some gaps where the ground stations are too far from the user terminal to get a bounce off of a satellite. Inmarsat/Viasat, they're geostationary terminals that there are some, there's based on a geostationary orbit, there is some shading when you start getting into the very high north and south poles, but otherwise they provide great global coverage. Also, last note on orbit patterns is when you have a user terminal on the ground, say you mount it on a vehicle, if you have a low Earth orbiting network, Iridium, Globalstar, these satellites move position in relation to the user on the ground constantly. If you have a blockage, you're parked next to a building, a geostationary satellite will maintain the same signal link margin because it's staying in the same place. That asset would need to move to see the satellite. Where in a low Earth orbiting network, you get more opportunistic transmit paths because the satellite network is constantly moving in comparison to the user on the ground. So it's a quick, not too deep review of majority of the L-band satellite networks, and we'll get into more detail with these as the satellite ecosystem continually changes. There's a lot coming out with D2D, which stands for device to device, 3GPP Rev 17, 18, and beyond that support the concept of a user terminal on the ground connecting via GSM or traditional GSM to satellite, how that's supported on GEO and LEO, how Starlink is playing in it, smaller companies like Satellite IoT, and how this is always evolving. And typically, those new carriers will also start competing against the carriers that we have utilized for the last 15 years. And so some of these new players are really starting to evolve into a competitive market space with them.
Jeff, thanks so much. I think it's so much to try and consolidate into a short, high-level overview, and that explains it perfectly. And it's one of my favorite features in GSAT tracks. I always love the click down, and you can do the different overlays for the different satellite networks and see the different satellites passing on our mapping page. And so it's a great feature. If you haven't used it, go check it out, and it helps clarify and explain a lot of what you mentioned in this podcast as well today, where you see the passing, and it also explains some of the latency and speeds that we exist with different products. And I look forward to chatting to you next week, where we go into some of the product detail of the products that we sell on each of these networks and how they work and what they do. I'll look forward to diving into some of the product details for each of these networks next week. Thanks, Jeff. Take care.
Absolutely. Thanks.